Okay, the first piece of coding we need to do is to be able to make the barrel go up or down. I was thinking of using the vertical axis for this, the up and down arrow keys, or W and S if you prefer. So I'm going to attach this to the barrel. The wheel is just decorative, really, it doesn't do anything. So I'm going to attach a script to the barrel object. And I'm going to call it Cannon Control. Create and add. It always seems to go into the wrong folder, but I'm going to move it up into the scripts folder. Just for neatness. Okay, and we'll start editing that. Right, so it's nice and empty. Wasn't quite ready. Right, okay. Now, I want to be able to control the speed of rotation here of the camera, so I'm going to create a public float. I'm going to call it C speed, Canon speed, and I'll give it a default value of 5. Remember, this is a floating point number, so it needs to have the F as well. Okay, we don't need anything in the start at the moment. We're not having anything in the update, but I'm going to have a fixed update. You remember that the fixed update occurs with every physics update rather than every frame. So it's better for time-dependent things like movement. Okay, so the first thing I'm going to do is get the input. So I'm going to have a float, I'm going to call it movement, and I'll get it from the input, get axis, and it's going to be the vertical one. Okay, I'm going to multiply that by our speed, and to get this the speed down a bit to scale it, I'm going to multiply by time, delta time, because it would happen remarkably quickly if it wasn't for that very small piece there. Right, now I'm going to create a vector 3. And I'm going to call this C rotation. It's the Canon rotation. And that's going to be a new vector 3. Now remember, I'm rotating this around the z-axis, so the x and the y components are going to be 0, and here I'm going to put movement. Okay, there we are. Now, I only want the movement to take place within a certain range. I don't want to be able to move the cannon right over on its back. So I'm going to limit that rotation. So I'm going to create another floating point variable. And it's going to be a new rot, a new rotation. So I'm going to take the original rotation, which we get from transform.rotation.eulerangles.z, and I'm going to clamp it. So there's this function called mathf.clamp, which clamps a particular variable to certain limits if it tries to go outside of those. Okay, so I'm clamping the transform rotation dot angles, and just the Z component. I'm not interested in anything else. And I'm going to clamp it minimum value 0, maximum value of 70. So that goes between 0 and 70 degrees. So if we try to rotate it beyond that, it will not work. And I'm going to add on to that, because this is going to be the new rotation, our movement. And remember that movement might be negative as well as positive. Okay, so that's going to be our new rotation. Now, if that new rot is less than or equal to 70, F, and if new rot is greater than or equal to 0F, we're okay, we're still inside our allowable limits. I'm going to rotate it by that. So rotate, C, rotation. Okay, and close the brackets. Just check that, see if that's any problems. And we don't appear to have any problems. So let's go back to Unity and try it out. So we've got the script here. It still hasn't read it in yet because I can't see the public variable yet. There it is. So we've got our C speed built in. Let's check it. So we should be able to rotate the barrel of the cannon. It goes up, and it should stop at a maximum of 70 degrees. Okay, it has stopped. 70 degrees is quite big, isn't it, really? And if we go the other way, and it stopped again, even though I'm pressing the button. Okay, so it's clamped it. Very good. Next thing we have to do is to be able to shoot cannonballs. But that's another story.